and it is going to check the conditions in peripheral devices as well as the interfaces. There will be single clock signal which enables both the sender and the receiving component. Only the slave or the receiver is ready for receiving the data, then only the master or the sender can send data, or the time delay it takes to transfer a data will be equal to slave's response time. Hello students, welcome to the next session of Digital Electronics. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram First Grade College. Let's start this session. This session is all about knowing what is a synchronous data transfer and something about the input-output commands and other miscellaneous concepts. Let's start this session. The first thing we need to know is the various input-output commands that can be used in input-output interfaces. So we have the input-output commands. Input-output command is an instruction or a line of code that is executed. Why do we execute this? In the interface, and it is attached to the peripheral units. To send an instruction, to send a command, we make use of different input-output commands. So these are the input-output commands that is executed in the interface and its attached peripheral units. We have so many input-output commands that can be used. One of it is the control command. What is the role of the control command? The control command is issued to activate the peripheral. Activate the peripheral device which may be in idle state. Along with that, informing what does peripheral device must do when it is activated and is ready to be used. What does the peripheral device must do when a data comes in? Next is the status command. What does this status command will do? It is used to test various status condition. What kind of status condition? Related to the connected components. Status of the connected components will be tested by the status command, whether it is in reset state or set state, whatever it is. It will be checked by the status command, and it is going to check the conditions in peripheral devices as well as the interfaces. So in both the locations or in both the devices, interfaces, software as well as hardware component. In both the components, the status command is going to check or test whether the hardware and the software are in set condition or reset condition, because data can be accepted only when the peripheral devices and interface are in set condition. When there is a reset condition, you cannot send the data. Even if you send the data transfer will be failed because it is in a reset mode or in an idle mode. So to check whether the peripheral device or the interface is in set condition, the status command will be used. Then we have data output command. What does this data output command will do? It causes the interface to respond. How it is going to responding? How it is going to respond is by transferring the data from the bus into one of the registers. Already we have explained about the registers, how they are used. So the data output command, what it will do is, it will make the interface to respond by transferring the data from the bus into one of its registers. When there is a request for output from one of the output device, the data output command is going to make the interface react or interface to a set state, and it transfers the data from the bus into one of the interface, all right, or one of the register. Then we have the data input command. What does the data input command will do? The interface receives an item of data. One data will be received from the peripheral device and places it in its buffer register. Buffer is all about accepting the data, buffer register. So, when there is a data input command executed, the interface receives the item to be accepted or input to be accepted from the peripheral device, say normally the input device, and places it in the buffer register. So, we have command status, that is the status command, control command, status command, data input command, and the data output command. These are the few of the input and output commands that can be used in a computer peripheral devices. Okay, let's move on to the next thing, that is to know about the input-output bus and the memory bus. As we know, bus is what? It is a set of wires, isn't it, which is performing a particular task. We have the input-output bus and the memory bus. What does these input-output and memory bus will do? The input-output bus or the memory bus we use, the first is the memory bus is for information transfer between the CPU and the memory unit, the central processing unit and the memory unit. It is transfers the information between the CPU and the MU or the memory unit. Whereas the input-output bus is for data transfer or information transfer between the CPU and I/O devices through their I/O interface. So that is, bus is going to transfer the data or information between the I/O devices and the CPU. For this, we make use of the input-output bus. Alright, there are three ways by which bus can communicate with the memory and the I/O. How does it is communicating? Firstly, it uses two separate buses. There is no single bus. It uses two separate buses. One is to communicate with memory. It has to communicate with memory, and the other with I/O interface. Another one is communication with the I/O interface, CPU to I/O and CPU to memory. We have two separate buses and uses one common bus for memory and I/O, the transfer between the memory and the I/O. But separate control lines will be there. Common bus, one way is common bus, another way is using two separate bus. Second is use one common bus for memory and I/O but separate control lines. The third method is use only one common bus for memory and I/O as well as common control lines for both. So there are three methods by which you can transfer the data between the memory, processor and the I/O devices. Okay, then we have the discussion about the isolated and memory mapped I/O. The first thing is isolated I/O. What are these isolated I/Os? Many computers use a common bus to transfer the information between the memory and I/O. They use the common bus and separate input-output read-write control lines. There will be separate control lines but common bus. Data bus will be common, whereas the read-write control bus will be separate. In addition to memory read-write control lines. There will be IO read-write control lines separate and memory read-write lines which are separate. So it will have two separate isolated lines. Then we have the separate memory and IO address spaces. So next thing is to have a separate or isolated memory and IO address spaces that can be used and which increases the speed of execution. Okay, there will be distinct input and output instructions that are used, which are each associated with address of an interface register. They are connected with an interface register, and there will be separate input and output instruction which will perform the input and the output operation in the input and output devices. Okay, then we have the memory mapped IO. What does the memory mapped IO will do? A single set of read bar write control lines will be there. Memory mapped IO. Single set of lines will be there. There will be no distinction between the memory and IO transfer, which will be carried out on same data bus. Whereas the memory and IO addresses share the common address space. Okay, so both share the common address bus and reduces the memory address range available. Since it shares a single memory location, there will be less memory address range that will be available in the computers. So we can have isolated input, output and memory operations as well as integrated or combined input, output and memory mapped IO interfaces. Okay. Along with that, there will be no specific input or output instruction, and the same memory reference instruction can be used for input-output transfer. Along with that, there will be a flexibility in handling the IO operations by the isolated as well as the shared memory maps. Okay, there will be flexibility in shared memory maps, whereas isolated is not that much flexible. Okay, next is to know about one of the data transfer method, that is the synchronous data transfer. Okay, a synchronous data transfer, how does the data is going to be transferred? How we can set and reset the devices or interfaces? Let's check with this. The first thing is, in a synchronous data transfer, the sending and receiving unit will be having a sender as well as a receiver to transfer the data, isn't it? So we'll have a sending and receiving unit that are enabled with single clock signal. There will be single clock signal which enables both the sender and the receiving component. Okay, it is possible between two units or two components when each of them knows the behavior of the other. When they are already synchronized, that means synchronous means they are in same state or in same condition to work. If you want to communicate with two components, they must be in same state. If they are in same state and are transferring the data between each other, it is called as the synchronous. You know about the term sync, isn't it? It is matching. Synchronizing is matching, isn't it? So there will synchronous data transfer is possible only when the sender and the receiving unit knows the behavior of the each other and they are in pair with each other. There will be two parts, that is the master and the slave. What are these master and slave? Let's look at that. There will be a master. The sender can be considered as a master. The master performs a sequence of instructions. The master performs a sequence of instructions for data transfer in a predefined order. Before the communication starts, there will be communication of how the data will be transferred, on what path the data will be transferred. Everything will be communicated between the sender and the receiver. Only when both the sender and receiver are ready, sender is ready to send the data and the receiver is ready to receive the data. Only at that stage, the set state will be done and the data will be transferred. So we have the master who performs sequence of instructions. There will be step-by-step instructions that happens when there is a data transfer. Okay, all these actions are synchronized. As I said, they must agree upon the mode of transfer, how much speed the data will move from sender to receiver. All the conditions will be synchronized with the common clock. Okay, same clock, common clock will be set for both the master and the slave, or the sender and the receiver. After that only the data will be transferred. So in a synchronous data transferring task is taking very less time and effort when compared to the efforts that happens before the data is transferred. To synchronize between the sender and the receiver, or the master slave, is the main part of data transfer in synchronous data transfer mode. Okay, the master will be designed to supply the data. He is the supplier or sender of the data at a time when the slave is ready for it. So when only the slave or the receiver is ready for receiving the data, then only the master or the sender can send data, or else the data will be rejected by the receiver. So only when slave or the receiver becomes ready, the sender can send the data. Okay. Generally, the master will introduce sufficient delay. There will be time delay or time interval to take into account the slow response of the slave. There will be receiving and sending of the acknowledgements. Acknowledgement is nothing but the sender will send the IP address, the packets, the data IDs, which are to be transferred to the receiver. Slave, when he receives it, he will not immediately respond to the sender that I am ready to receive the data. Instead, he will wait for some time so that the sender sends all the related information before the data is transferred. Once all the information is received, then the slave will be ready to accept the data or receive the data. When he is ready, he will send a message to the sender that I am ready to receive the data. Now you can send the data to me. Then only there will be the sender who sends the data. That means at the time, from the start of the time when sender starts sending the prerequisite conditions and the receiver receives all of it and sends back the acknowledgement that he is ready, there will be a time delay. How much time delay is allowed? The sender cannot wait for indefinite time, isn't it? Up to infinity, he cannot wait. That receiver will send the acknowledgement that I am ready. So the sender will set a time delay. Before that, the receiver has to send the acknowledgement that I am ready. Otherwise, the sender thinks that the data, prerequisite data have not been received by the slave or the receiver and is failed. So he will resend the same data. Suppose if an item is not delivered to a person which I have to send, what I will do is, if there is a failure in the delivery, what I can do is I will resend the same item or the product, isn't it? So in the same way, if the receiver, if not sends any acknowledgement or response to the sender that I am ready to receive the data, the sender or the master will resend the data. He will take into account the slow response of the slave without any request from the slave. Before sends it saying slave that I need a time, sender himself will give some time delay and waits for that time delay to end to resend the data. Before that time delay, if the receiver sends the response, then the master or the sender will get to know that the receiver is ready to receive the data. Okay. What happens next is the master does not expect any acknowledgement signal from the slave. This is one type. When the sender does not wait for the receiver to send the acknowledgement. Instead, he will wait till time delay, and without any acknowledgement from the slave, he will send the data to the slave. He doesn't worry about the acknowledgement is received or not. He will wait for time delay. Say if it is 30 seconds, say it is the largest one. So 30 microsecond you can take. Say for example, I take 30 seconds only. The sender will wait for 30 seconds. And without worrying whether the prerequisite conditions have reached the receiver or not, the sender will move the data to the receiver or to the slave. When the master does not expect any acknowledgement signal from the slave, when data is sent by the master to the slave, he sends the data as it is. In the same way, similarly, when data from the slave is read by the master, if the slave sends a data to the master, neither the slave informs that the data has been placed or data has been transferred on the data bus, nor the master acknowledges that the data has been read. I have received and read the message. None of them will communicate about the confirmation of the data received and read. So this is the method of synchronous data transfer. Now there is a modification that you need to send the acknowledgement. Sometimes there will be no time to receive the acknowledgement. There will be too many messages exchanged between the master and the slaves. In such a case, neither the master waits nor the slave waits, neither the master acknowledges nor the slave acknowledges. There will be only data transfer. Nobody will be knowing whether the opponent, whether the receiver has received the data and read it. The thing is, only the data will be sent over the communication path, over the data bus, without worrying whether the data is received or not. That is the synchronous data transfer. Okay. In this, both the master and slave perform their own task of transferring data at designed clock period. At that clock period, the data will be sent. Since both devices know the behavior, the response time of each other, in which time the response, how many time slot or time delay is needed to get a response time, there will be no difficulty arises. One of the beauty of the synchronous data transfer is that we know about each other, so no need to send the acknowledgement. You can just transfer the data as is varies condition. You can transfer the data. That is what happens in a synchronous data transfer. Before transferring the data, the master must logically select the slave. How does he is going to select the slave is either by sending the slave's address or sending device select signal to the slave. There will be multiple receivers. The sender has to select who is the receiver. So to select a receiver, the sender or the master can perform two methods. He can just logically select the slave or can send the device select signal to the slave that you have been selected as a slave or a receiver, or the master will logically select the slave by sending the slave's address to he will broadcast the slave's address to all the slaves. When the determined slave receives that address, he gets to know that he is the one who is going to accept the data. Okay. But there is no acknowledgement procedure. We don't have any acknowledgement signal from slave to the master if the device is selected. There is no acknowledgement procedure. Only task will be done by the sender. Okay. There will be timing diagram of the synchronous read operation which is given below, which explains that in this timing diagram, the master first places the slave's address in the address bus. First there will be address in the address bus and read signal in the control line at the falling edge of the clock. Falling edge is negative edge of the clock. The signal will be read. The entire read operation is over in 1 clock period. Reading a data by the receiver will be done in 1 clock period. Here we have the timing diagram of the synchronous data transfer. Here we have the clock. This is the negative edge. This is the negative edge. And this is the positive edge. 0 to 1 is the positive edge. 1 to 0 is the negative edge. So, it is the address of the slave master that will be sent. Read the signal by master. In 1 clock period, all the task will be finished. Read signal from the master. Data is placed in data bus by the slave and is received by the receiver. Okay, so this is the timing diagram of the synchronous data transfer. What are the advantages of synchronous data transfer? Let's check about the advantages of the synchronous data transfer. The design procedure of synchronous data transfer is very much easy. The master does not wait for any acknowledgement signal from the slave, though the master waits for a time equal to slave's response time. Even though the master waits for some time to transfer the data, he doesn't receive any acknowledgement. The time he waits or the time delay he takes to transfer a data will be equal to slave's response time. Even then, the master does not expect any acknowledgement. Along with that, the slave does not generate any acknowledge signal. Though it obeys the timing rules, even though it obeys the timing rules as per the protocol set by the master, but he doesn't go to or doesn't worry about sending the acknowledgement signal to the master. These are the advantages. It saves the timing of data transferring. When you look at the disadvantages, what are the disadvantages of the synchronous data transfer? If a slow speed unit is connected to a common bus, if we use a slow speed unit, it can degrade the overall rate of data transfer in the system. There will be so many time delay because of the slow speed unit. It delays the data transfer much more than the normal operation. Okay. Another thing is, if the slave operates at a slow speed, if he is slow, the master will be idle for some time during the data transfer. So, the master has to sit idle if the slave operates at a slow speed. Same way, if the master is in slow speed, slave has to wait until the master sends the data. Another disadvantage is, if the slave goes down, if he goes down not receiving the data, the master will not get to know whether the data is received or not, because there is no acknowledgement system in the synchronous data transfer. Same thing, if the master goes down and is not transferring the data, slave will wait until indefinite time because he doesn't know whether the master is sending the data or not. He has to wait for indefinite time. These are some of the disadvantages of the synchronous data transfer. This is all about the synchronous data transferring in a computer system. More about the computer working and organization we shall look at in the next sessions. Thank you.